So those off-balance diagrams are good to see how visually things will fill up from lower energy to higher energy. But we're going to have to use a normal configuration, electron configuration chart, because we're going to be writing out electron configurations, and we're not going to really have the luxury or time to have an off-balance diagram in front of us. So this is kind of a cool little diagram showing not only the electron configurations and the order, but also what the orbitals would look like. So in the 1s, this is what an orbital would look like. 2s, 2p, the 4f orbital over here, 4d orbital. And as it says, electrons fill in shell and subshell levels in a semi-regular process as indicated by the arrows. Now we'll give you some other charts that will give you the orders. Now this is a chart to tell you what order the electrons will be filled in. Now this main number, that's the energy level. The S is the type of orbital, and this is the number of electrons. This is the max number of electrons, 2. So the S can only hold 2, the P can hold 6, the D can hold 10, the F holds 14. Now there are many different charts here that you can use. You just pick the one. I've put a bunch of different ones in your Chapter 5 tab, so you can pick the chart that you like. Doesn't matter. Whatever is easiest for you to understand and follow. So you would start here and you just follow the arrows. So you first fill up the 1s2, then you go to the 2s2, then after that basically go here and then back to the top, fill up here, then go back here, fill up these, and whoops, and then you go back to the beginning, back to the front of the line, the back of the line. You go on your little ride, you go back to the ride, go down the slide, and then go back to the back of the ride, go all the way down, and then you have to go back of the line and go all the way down. So you just follow the yellow brick road as it says here to write an electron configuration. And let's look at one. Let's look at boron again. Electrons equals 5. So how are we going to write that electron configuration? Well, we start here. We have 1s2. That's 2 electrons. Then the next thing we go is here, 2s2. 2s2. That's 4 electrons. And so we need one more. We go here, and that's 2p1. So that's 5 electrons. So that's boron. It's 1s2, 2s2, 2p1. So it has 2 electrons in the second energy level, 3 electrons in the second energy level, 2 in the s orbital, and 1 in the p orbital. Let's try sulfur. Sulfur has 16 electrons. So we start here. So we have 1s2, 2 electrons, so we need 14 more. We go back to the back of the line. 2s2, that's 4 electrons. We need 12 more. We go to the back of the line here. 2p6, that's 10 electrons, and 3s2, that is 12 electrons. We need 4 more. And then we go to this one, 3p4. Sulfur's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4. And we see that it adds up, 2 plus 2 plus 6 plus 2 plus 4 adds up to 16 electrons. Now this is another example if you want to use this one. It's basically the same. Then there's also this, which might show you just follow the arrows. Maybe it's more exact for you. This also, I made this one. just follows you just follow down and then go back up, down, then go back up. This is another one. I usually use something like this. It's just, to me, I kind of like the representation where you're going to a higher energy level. So you're climbing steps to higher energy level and then you go back down. So let's just try some more. Again, it doesn't matter which electron configuration chart you use. You can find others online. So let's look at a more complicated one. How about arsenic? AS, so that has 33 electrons. Okay, so we start at 1s, 1s2. Now the thing is, this might not tell you, this doesn't tell you how many electrons it has, but at this point you should really know. So S holds 2 electrons, P will hold up to 6 electrons, a D orbital holds up to 10 electrons, and an F orbital holds up to 14 electrons. So just knowing that, we can just, and we don't really need the reminder anymore. So 1s2, we need 33 electrons. Then it goes to 2s2, that is 4 electrons. And we go back down here to the bottom. It's 2p, 6 will hold 6, so that's 10 electrons, and there's a 3s up here, 3s2, and then we go back down, 3p6. So how many electrons do we have, just so we know what we're doing here? We have 10 plus 8, that's 18 electrons, and we need 33. Then we go up to 4s2. So that's 20 electrons. Then we go down to 3D. So that's 20, 3D, 10 holds 10. That's 30. So we only need 3 more. And then we go to the 4P with 3 electrons. So this should add up to 33 electrons. And that's the electron configuration for arsenic. Okay, let's just try one more. Barium. See if you can get this as well. Trying it at home. Has 56 electrons. 2s2. 2p6. 3s2. 3p6. 4s2. Down to 3d10. 4p6, 5s2, so we have 38, 4010 is 48, 5p6 is 54, and we need 6s2 is 56. So that's the electron configuration for barium.